Section 3. In our previous section, we looked at solving quadratic equations by graphing. Today, we are going to solve quadratic equations using square roots. Now, we can only do this when our quadratic equation is in the form of ax squared plus c, some constant, is equal to 0. Notice that there's no linear term. There's no bx term. So when there's no bx term in there, we can solve using square roots. Now, when we have this situation of ax squared plus c is equal to 0, and we whittle it all the way down to get x by itself, and we have x squared set equal to d, and d is some positive number if it's greater than 0, then there will be two real solutions. It will be the positive and negative square roots of d. However, if we whittle it down to x squared equals some number d, and that number d is equal to 0, then there's only going to be one real solution, and that real solution will be x equals 0. Our third case is when x squared is set equal to d, and d is a negative number. It's less than 0. That's the case where there are going to be no real solutions. So you may remember this graphically from yesterday when our parabola crossed the x-axis in two distinct points. That's when there was two real solutions. When it touched the x-axis in one point and changed directions, that's when there was one real solution. And then when our parabola hovered above or below that x-axis and didn't cross it, that's when there was 0 real solutions. So we're going to have the same 3 different types of outcomes today. Let's see how this plays out in our examples. Solve using square roots and tell how many real solutions the equation has. So we have 2x squared minus 32 is equal to 0. Notice that there is no x term, so we can solve using square roots. We're going to move the 32 over. That gives us 2x squared is equal to positive 32. Divide off the 2, and now x squared equals 16. So I can take the square root of both sides, and x, my solutions will be both the positive and negative square root of 16, which is 4. So I have 2 real solutions. Those 2 real solutions means that it's going to cross the x-axis in 2 distinct points at positive 4 and negative 4. All right, let's take a look at our next one, example B. We have 1/2 x squared minus 8 is equal to negative 8. So again, there's no linear term, there's no bx term in there, so I can solve using square roots. I'm going to bump my 8 over by addition, and that gives me 1/2 x squared is equal to 0. Now I need to multiply this 1/2 over by multiplying both sides by 2. Well, 0 times 2 is simply 0, so I have the statement x squared equals 0, and when I take the square root of both sides, I get one real solution, and that one real solution is 0. All right, in our next example here, we have negative 2x squared plus 3 equals 27. We're going to start off by subtracting 3 from both sides. That gives me negative 2x squared is equal to 24. Now dividing by negative 2, I have the statement x squared is equal to negative 12. So here's my statement where d is going to be less than 0. In other words, it's negative. And if I try taking the square root of this, my calculator will return an error message to me. I cannot take the square root of a negative number. So here I say that there are no real solutions. All right, in our next example here, example 2, it says, recall that solutions are also x-intercepts of the graph of the function ax squared plus c equals 0. Solve using square roots, then give a graph of the function to check your answer. All right, in example 2a, I'm going to see that I have this x minus 3 quantity squared is equal to 16. So I can start by undoing the square on both sides to begin. Now that leaves me with just x minus 3 equals both the positive and negative square roots of 16, which remember is 4. So that means x minus 3 equals positive 4, and x minus 3 equals negative 4. Oops, I forgot my negative there. So when we undo that square by taking the square root, we have to allow for both the positive and negative outcomes, and that's going to lead us to our two solutions. X minus 3 equals 4, so now if I add my 3 over, that means x is 7, or when I add my 3 over here, I'm going to have x equals negative 1. So my two solutions are also my two x-intercepts. Those are 7, 0, and negative 1, 0. All right, so if we were to kind of do a little bit of a sassy sketch here, I'm going to just kind of graph this with my intercepts here at positive 7 and negative 1. To get my vertex, now if you notice that we're kind of in vertex form, if I have x minus 3 quantity squared, and if I move that 16 over and set it equal to 0, my vertex here would be 3 comma negative 16. So if I go 3 over and down to 16, there's about my vertex. And I see that my a value is 1, so I'm going to go to the right one and up 1, to the left 1 and up 1. And so I have enough points here. I can plot my parabola, and that's kind of a basic sketch of what that graph would look like. All right, let's try letter B together. We have 2x squared plus 10 equals 32. Again, we don't have a linear term in there. There is no x term. So we can solve using square roots. We're going to start by subtracting our 10 over. That gives us 2x squared is equal to 22. And now we're going to divide by 2. All right, that gives us x squared is equal to 11. Now when we get here, we're going to take the square root of both sides, and we get x is equal to both the positive and negative square roots of 11. And it's okay to leave it because 11 is not a perfect square. If we were to put this into our calculator, we would get something like x equal to both the positive and negative, and it would be, somewhere right around 3.19 or something like that, okay? And you can check that on your graphing calculator just to see what that looks like. But if we were to give this a graph, we could put out our x and y axis here. And we have just the graph of x squared here, and it's going to have the intercepts here positive and negative, pretty close to 3, all right? And our vertex is going to lie on that the y axis, and we can kind of give it a good sketch here, and get a good idea of what that parabola would look like. All right, let's flip the page over here. We've got one more of those examples. We've got 2x plus 1 in parentheses squared is equal to 36. So again, we have the term here that's being squared is isolated. So we're going to get rid of that square right away by taking the square root. That gives us 2x plus 1 equals the positive and negative square root of 36, which is 6. So from here, I want to write two equations. 2x plus 1 equals positive 6, and 2x plus 1 equals negative 6. All right, now solving for x, we're going to subtract 1, and that gives me 2x equals 5, and x equals 5 halves. Now 5 halves is just 2.5, so we'll write that as a decimal. And next, we're going to subtract our 1, and we get 2x equals negative 7, divide over that 2, and that's negative 3.5. All right, so once again, we have our solutions, which tell us our x-intercepts. And those x-intercepts are at negative 3.5, so we'll go out here and say that's negative 3.50, and then positive 2.50, so here's 2.5, positive 0. Our parabola opens up, and we can see that it's going to be difficult for us to find that vertex point, but we just give it our best shot there, our best sketch of a parabola. It's a little bit off-centered, but you get the idea how you can kind of get that graph just by finding those intercepts. All right, one more example for today. It says a storage container in the shape of a rectangular prism has a height of 6 feet, so we can see that height here on that back edge. Its length is 2 times its width. So we'll say that the width of that container is x, because we don't really know what it is. And so the length is 2 times that, so we'll say that must be 2x. And then it says the volume of the container is 288 cubic feet find the length and the width of the container. So remember, volume is length times width times height. So if we take all three of these dimensions and multiply them, we will have x times 2x times 6, and that should be equal to our volume of 288 cubic feet. All right, so multiplying these together, we get 12x squared is equal to 288. Now we're going to divide off that 12, and that leaves us with x squared, and that x squared is going to be equal to 24. All right, now we need to take the square root of both sides there. X is going to equal both the positive and negative square roots of 24, and we'll just leave it like this because 24 is not a perfect square. However, within the context of the problem, it doesn't really make sense for us to have a negative length here. So we're really only looking at the positive square root of 24 is going to be the value of x, and therefore the value of 2x would just be 2 times the square root of 24. All right, that's it for our notes today. We will finish example 4 in class tomorrow.